Hello, everyone, and welcome to the very first Elixir Community meetup done by Software Mention. At first, I would like to briefly introduce our company. Our journey with Elixir started around 5 years ago when we started developing our open source multimedia framework called Membrane. And since then, our team has grown significantly. We started doing backends in Elixir, a lot of work with Phoenix. And right now our team is around 30 developers, Elixir developers. And we decided it's a high time to organize such an event for the community. Obviously, this is the first time we're doing this, so we apologize for any mishaps that may happen. And if you have any ideas for next presentations, feel free to contact us. And right now, we'll just go to our first presenter, Jonathan Kłosko, who is the main developer behind Livebook. If you follow José Valim on Twitter, you may have heard of Livebook. Jonathan, the stage is yours.
Hi, thanks for having me. So my name is Jonathan. I work at Dashbit, and for the last year, I've been focused on Livebook. That's what I want to talk to you about today. And so the plan is that I will give some context, just to make sure we're all on the same page on what Livebook is. And then I will go through a number of use cases and kind of showcase what you can do with Livebook. So as you can see, I'm running in the browser, and that's because Livebook is a web application. So we can run it either locally or in the cloud, which we will also do. And Livebook is primarily meant as an application for, or rather as an environment for creating and executing code notebooks. So I will go ahead and create the first one. Yeah, and as usually with documents, we can change the title just to make sure, just to show to the user what notebook's about. And then we already have a section inserted for us. So the section basically groups related content into logical pieces. And the whole notebook is built on top of two primary building blocks. So we have Markdown for describing the code, for kind of describing the concepts that we are about to discuss. Right, and you can see the preview as we type. And then we also have Elixir snippets, where we can pretty much put arbitrary code, and then we can run the code, right? So we immediately see the result of the evaluation, and that's like the basic idea behind notebook systems in general. But the question is, what primary aspects do we want to address with Livebook? And one of the key goals we had from the very beginning is reproducibility. So let's say we define a variable, and so we can evaluate this code. This variable is defined in the memory, and now we have another piece of code that depends on this variable. Right, if we evaluate this code, we see that the code is evaluated sequentially from the top to the bottom, as we would expect. But the key here is if we remove this code, so this variable is no longer defined, or at least it shouldn't be defined, we can clearly see that this cell that depends on it, it's marked as stale, which means the result is no longer up to date. Right, and if we evaluate this code, we can see an error, as we would expect, and that's because we evaluate everything sequentially, right? So that's one of the primary goals we had, because in many notebook systems, the memory is global. So if you define a variable somewhere, it becomes available forever, even if you change the code entirely. Right, so now we can revert this, and if we run this again, everything's green back. So that's the most important point. And then the same applies to dependency management. And for that, we actually use just Elixir features. So like there is nothing livebook specific about the way we handle dependencies. So let's create a new section and try out to make some HTTP requests. So the function for bringing in dependencies is mix install. It came in Elixir 1.12, and it basically allows you to list the dependencies the same way as you would do in a mix project. So, right, we can try out, for example, REQ. And then once we install the dependencies, we can just use the package as we would expect. And get the response. So this basically allows for quick code prototyping, because now we can easily change this code and keep re-evaluating to iterate on our prototype, right? And then we can just take this code, put into our actual editor or into our project, and we are done. And you may have noticed that we actually show documentation on Hover. So that's also an important point, that we want to kind of create an immersive experience for the user. So if you are discovering a new package, you can easily discover the API and play around with the library itself. And if we would proceed this notebook, so here we have this document, and what we can do with it once we are done. We could save this notebook, and just to quickly show how it would look like, I'm gonna go to the export section. And as you can see, it's basically Markdown. So all of the code becomes Elixir snippets, and all of the rest is just Markdown by design. So the reason why this is important is that it means the files are readable whenever we share them or do anything else. So I actually have an example here. So just recently, Jose submitted a pull request that basically rewrote a number of guides that come inside Livebook. And as you can see, the changes are pretty clear, and it's like it was very easy to go through the changes and make suggestions, both to the code and to the actual content. So that's like the second point that we wanted to address, to make the notebook easily shareable between people and enable collaboration on review level, basically. Right, and just to reiterate, and going back to the previous example, if we took this notebook and send it to somebody else, because we make the evaluation sequential and predictable, plus we also specify the dependencies by listing the dependencies and diversions, this notebook should be reproducible for somebody else just to run it. So I hope overall this gives you like an idea of what Livebook is in a nutshell. And now I want to go through a couple interesting use cases for Livebook. One feature that I didn't discuss at this point is collaborativeness, but to give it more context, we will try running Livebook in the cloud. So currently, as you can see, we are running locally. But since this is a web application, we can actually run it anywhere. So if you go to the website, in particular, we can see that there are Docker images, which means it's fairly straightforward to run it on any cloud provider. And in particular, Fly.io, that is our partner, they build a custom launcher for Livebook. So basically, you can sign in, put the password, and in like a minute, the application is running. So this is also pretty cool because it allows like people to quickly jump into Elixir and into programming without really installing anything on their machines. And I have an instance running on Fly.io already. And I'm gonna use that to showcase some of the collaborative features we have. So I will start with like an example notebook we have, and I will simulate multiple users by opening a new window. Just give me a second. Yeah, so these are two users at this point, or rather two instantiations of myself. And right, as you can see, as we make changes to the notebook, as we type, the changes are synchronized between the users. And more interestingly, they can see each other all each time. So if I select something here, the other user can see where I am, what I'm editing. And also they can simultaneously type in the editor, and we will synchronize the changes so that in the end they end up with the same state, even if there is like latency in the communication. And one particularly interesting feature is pinning. So if there is another user, we can pin to himself. And then as we move focus on the right, which is the followed user, the other user focus moves basically in the same way. So this makes for a good tool for like pair programming or doing teaching, code interviews, this kind of stuff. And yeah, so basically with this context, you can see that Livebook can be useful for just day-to-day programming and prototyping code, right? Playing around, kind of like in IEX shell you would do, except you have an editor, so you can change things around, move things around, and then eventually persist them. So that's like one group of use cases for Livebook in general. But having all of that, we can ask a question, what kind of content would make sense to put inside notebooks in general? And there is one particular interesting feature in Xdoc that was added recently, and it basically allows for putting notebooks inside documentation and running them. So I have an example package over here, and basically there is this guide section, and usually we can put arbitrary markdown files there as some sort of tutorials for the given library. And in this case, we included some notebooks in the documentation, right? So as you can see, it's all readable. There are code snippets, as you would expect with regular Markdown. But there is also this run in Livebook badge. And what it does is basically it redirects to the Livebook website, and it asks us where we want to import the notebook. So we can go through the preview of the notebook. We can configure the location where our instance is located. So this could be either localhost, this could be the cloud instance that we had. And then if we proceed with that, we can see the notebook imported directly into our environment. So then it's like we can still read the guide and go through it step by step, but we can also actually evaluate all of the code that is in the guide. And this sort of bridges the gap, or rather makes the smooth transition between the user reading examples and reading about the package and actually trying it out and playing around. So it kind of smoothens the curve for getting into the library. And in particular, since we have the documentation integrated inside Livebook, they can easily see what various APIs do without jumping around within the documentation. They can change values, basically play around with the API and kind of immerse themselves in this environment. Yeah, so as in this case, it takes a bit longer, and you can see that there is a timer that shows the computation, which is particularly useful for cases where you're doing like machine learning and training neural nets. So then you can see the timer going on. And yeah, took a bit longer this time actually. And there's another notebook that showcases another new feature. So if we go through the same flow, we open the notebook, and this time we are including Vigolite for plots and Kino for Kino is like a Elixir API for interacting with Livebook within a Livebook. So it allows for rendering interactive widgets and components directly in Livebook. So if we evaluate some of this code, this basically optimizes a function using an evolutionary algorithm. And as a result of this run, a number of metrics is gathered. So then this package provides a function that basically takes the metrics and creates plots over time of those metrics. So if we evaluate that, we can see all of the graphs rendered directly in Livebook. And more than that, they are actually interactive. So you can like zoom in, zoom out. And the best part is that it's not really Livebook specific. If we look at the data structure returned, it's just a Vigolite struct, and Vigolite is just a graph representation. You could use this in a Phoenix application, or you can directly export this as a PNG or whatever. And like the way it works is basically we have a protocol inside Kino, and Livebook recognizes that the returned struct, which is a Vigolite plot, is something that we can render in a special manner. So in this case, we use the VigaLite package to render it directly. And there is much more you can do with Kino in general, but we'll hopefully get there as well. Yeah, so that's another thing. And moving forward, as I mentioned, basically one use case is like day-to-day programming. And what we do oftentimes is basically we develop projects like web applications and stuff. So how can we leverage Livebook for exactly that purpose, right? So let's say we have a Phoenix application and we want to interact with that application from Livebook as we would do with like IDXRL, for example. And one way to do that is to go to the runtime, and instead of starting a separate Elixir environment, which is bare bones generally, we can pick the mixed runtime and choose the project that we want to work on. So this will automatically compile the project, get the dependencies, all of that. And having that connected, we can interact with all of the internal modules that we have. So in this case, we get the completion for all of the modules that are a part of the application we are building, right? And we can read the documentation, explore the APIs, and run the code. So the reason this is powerful is because now you can create notebooks specific for the project and the business domain. So you can describe like business concepts and also showcase them via code. So new developers joining the project, they can just go through the series of notebooks and kind of familiarize themselves with the application without really, just jumping around the code base. They can have like a tutorial that literally tells them what this application does, what are the main areas, and yeah.
Sorry, there is a problem with the stream.
Okay.
Zobaczyć jeszcze, ale dasz czas się podłączyć.
Otwierać?
Spróbuj szerować.
Jeszcze raz to zrobię, dobra? Usunę go.
Było przez moment.
Się rozłączy.
Wcześniej było to.
Tak.
Okay, so we are back, it seems. Yeah, so that's one way of running. And the other way would be like, if this is a Phoenix application, we likely want to start the application itself. And in order to do that, let's go to the project directory. And usually we would do like ix mix, right? And the trick we can do is pass a name. So we start a named node within the mix context. This could be app, we need a cookie, also an app, right? And this would start the Phoenix application. I'm not sure if I missed something, but let me just try. Yeah, I'm not sure why the endpoint isn't running though. But basically, what we could do later on is instead of using the mix runtime, we could attach to the node. So the name we gave to the node, we could pass it here, and we would basically connect to the application, which should give us the same environment. Yeah. I'm not sure why the endpoint isn't running, but let's keep that for now. And going back to the presentation, we saw a number of use cases related to like documenting things, and there is one trick in particular that I really like. So I have this repo where I put all of my notebooks usually, and they are grouped inside directories. So there's a bunch of them, and I have an index file that is basically like a table of contents for the notebooks. And here you can see the other notebooks are linked relatively. So if we now go and import this main notebook, which we can do through the Radio Livebook badge, we can see this kind of table of contents imported in Livebook. And now if we navigate to a relative URL, we are also we are automatically importing the other notebook directly inside Livebook, which means you can create like multi-chapter books or tutorials, and people can just import a single thing and then go through it by step. And since we are here, we can also try out what the notebook does. So we are installing a couple of dependencies. And one thing that, so I mentioned Keynote previously, which allows for rendering custom widgets inside Livebook, right? So in this case, we can render like an input box that we can read from later on. And in this case, we are scraping the IMDb website, right? And basically getting data about a movie that we search for. So if you go to the end, we can see that we downloaded some data by doing web scraping, and then we use Keynote to render it as a markdown, so in a kind of nicer form. And so that's one of the things you could do with Keynote. And another particularly interesting feature is that we mark this cell as re-evaluating automatically, which means that if at any point this result becomes stale, as we change things around, it will automatically evaluate and update itself. So if we change this to another movie, we can see that the code runs automatically, and eventually it should update just this way. So in a way, you can prototype like interactive scripts or build like super fast prototypes. And there are also ideas we have to take this even further and allow you to deploy this notebook as an application, which would hide all of the code and make just, so we would show just the input and the output, and the user could play around with it as if it was an app. So yeah, that's one of the things we could do. And hopefully at this point, this gives you an idea of like two areas that Livebook can be leveraged. So like day-to-day programming, prototyping, collaborating, and then creating actual write-ups with interactive code inside them. And yeah, I guess that's it for the use cases that I sort of identified. We also know that some people are using Livebook for like code interviews, for example, and they actually use XUnit to, so they have a bunch of tests with XUnit, and they use Keynote for people to input data, right? And the interviewee is basically meant to like implement a piece of code and make sure that all the tests are passing. So there are many directions that that you could take this. And since we have a bit of time, so I will stop here and ask if there are any questions at this point, because I can talk like much more, but it would be interesting to see if you have any questions. So there's something up at the chat apparently.
If anyone has a question, here's a mic, so the people on the stream can hear this as well.
Yeah, so what we can keep in Livebook is, let me just go through. Oh, sure. So the question is, do cells get garbage collected once they go stale? And so the idea is that if we change the code, let me just disable this so we can more clearly discuss the matter. So if something changes, we can still see the results, right? But once we reevaluate this, all of the previous variables, all of the memory that we used to keep the data, it is the garbage collected. So like pretty much, yeah. That would be a simple answer to that. And the other question is, I guess that Livebook would assume that we are a trusted party. If we can use any of Elixir code, we can as well do file remove the whole file system. And sure, that's true. So that's one of the things we kind of wondered initially. But the point of livebook is basically arbitrary code evaluation. So like the whole point is to run arbitrary code. So basically, if you don't trust the people using your livebook, you can protect it with a password. The best way is to just put it in the cloud, because then it's limited to the given cloud instance, so people can do arbitrary stuff and you are not really affected. And even locally, you can also use Docker to sort of sandbox the execution, right? And one thing that I could mention, if we go back to the web instance, is that usually the storage is temporary, right? But we would still want to persist notebooks and stuff. So one way to do this is by plugging in an S3 compatible bucket, and it then becomes a virtual file system essentially. So we could change this to the S3 file system and just navigate around as we would otherwise. So basically, we can still get persistence, but run in the cloud in a isolated environment, which should hopefully minimize the possible security vulnerabilities, or yeah, just like that. So that would be it. Either any other questions? Just let me know. Sure.
My question is, what are the plans for the upcoming version? What are you focusing on right now?
Right. So I will soon talk about the version that we just released yesterday. But one of the goals that we had is basically what I said about the so-called presentation mode. So let's say you write a notebook and you have a couple inputs. You can have charts and this kind of stuff. And the idea would be that we take this notebook, essentially with a single button, deploy it, and then you get like an URL, shareable URL. People can jump in and use it as an application, change the inputs, see the results, and do this kind of stuff. And this could be particularly interesting in the context of machine learning. So imagine somebody training a machine learning model and then sharing it with other people so they can try different inputs and see how the model performs. Yeah, so that's one of the sort of mid-term plans that we have. But since we are talking about the features, I can as well just present some of the new stuff that we had. One of them is, so we published just yesterday. And one of the things is now we distribute a desktop application for macOS, and we also will have one for Windows relatively soon, which we hope will kind of minimize the barrier for people jumping into Elixir or into programming, because now you can download a desktop application and you have like Elixir, Beam, everything packaged there. So it's a single click and you can interact and learn about Elixir. But one of the super exciting features is defining custom widgets. So a couple of times I mentioned Kino as this package for interacting with Livebook essentially. And what this new version brings is an ability to define custom widgets with JavaScript, basically, right? So here's an example of the simplest possible widget you could build, which essentially takes HTML string and just renders it on the page, right? And we can see it being used over here, just like that. And we can take this further, right? And here's a more advanced example rendering a map, right? And then we can have we can make this stateful. So instead, right? So except all of this code that we have on the JavaScript side, we can have an Elixir server running so that it maintains the state, right? And to showcase this in a better way, I will again open a separate tab. And here we have like a public function for adding pins to the map, random pins. Some of them may not be in the view. Yeah. And you can see that it automatically adds the pins for both users. So not only you can define your own widgets, but it can actually be collaborative. And there's even a nicer example over here, which showcases like all of the possible ways people can interact. So they can either interact through the JavaScript, all right? We just handle button click, and we update the counter. There is also the Elixir side, so we can use the Elixir API to increase the counter as well. So there's a single server and multiple people connected, and this widget, as well as the map, they are built like without Livebook knowing anything about the map, the JavaScript libraries that we use. So this is pretty exciting because now people can extend Livebook pretty much any way they want and build interactive widgets. And one of the reasons this came out is that initially we had this component for rendering plots in Livebook. And the way it worked is basically there was a special output type that said like render a plot here, right? And it specifically used VegaLite, which is like a specific graphing solution. And then people started asking, well, so ideally we would like to put some maps in there, but the problem is that there is like a dozen of great libraries for creating maps and rendering maps, and we didn't want to like include this as part of Livebook itself because this doesn't really scale. People would request more and more of those widgets, and it would just increase the JavaScript bundle on Livebook side. So now we have this abstraction where people can define anything, and Livebook still stays lean without all of this custom JavaScript embedded inside Livebook. So this is probably the most exciting features, most exciting feature in the recent version of Livebook, and I would be interested to see what you can build with exactly that. I will see if there are any more questions, any more from the side. Yeah, so I guess this is it. Thanks very much. And if you have any questions following up, or if you have any other use cases for us to explore, then let us know. Happy to chat anytime. And thank you.
Thank you very much. Personally, I have to say I'm really excited about Livebook. I already started using it for benchmarking. Like I have a Livebook with Benchy installed, and it's super cool. And I'm really excited to see where this is going on. Thank you.
Thank you.
And now it is a time for another speakers. Two of my colleagues from the Membrane team. Our recent focus at Membrane was to create a platform for WebRTC solution, the tool for building a video conferencing room, since it's really popular these days. And we've managed to get some success. And next up is a live coding session done by Łukasz and Michał, where they will show you how to use Membrane to start Google Meet clone in a fairly simple way. Are you ready?
Just a moment, please.
As usual, technical difficulties.
So,
Okay, great. The stage is yours.
probably this, but there is still some technical issue as far as I've heard. Okay, I think now we are ready. So hello everybody, my name is Łukasz and I would like to welcome you to my today's talk. So today we're gonna discuss how to create your very own Google Meets clone. So simply what I'm gonna do, I will try to live code a custom video conference room with the use of the Membrane framework, which is a tool to which I have slightly contributed, and it's meant to be used for multimedia processing. Okay, so let's start with actually describing the goal. So what do we want to achieve? As I said before, we want to have a video conference room. So probably it will be better for all of us if I simply show such a room. So I will try to show you the expected result. So we want to have some kind of web application, and we want to have a place where we can put the room's name, as well as our display name, and we want to join to this room. That's the first thing. However, we want to communicate with other people, so we also want somebody else to join that room. And as you can see, we can see each other, and we could and we possibly could talk, but probably there's no point in talking to myself, so I will just leave it for a moment. And let's go back to the presentation. So to summarize, we want to have a browser application which will be capable of sending user media to the server and receiving that media from the server and displaying that media, of course. By media, I mean video and audio. And of course, the server, whose responsibility will be to relay that media among the browsers. So one might wonder why. Well, it's actually what Google Meets does. So why not to simply use Google Meets? Well, because Google Meets is not customizable. And our solution, based on the Membrane framework, will be customizable. Or I hope so, at least. So now, before going to the coding part, maybe let's try to think about the architecture of our system. So as I said before, we're going to have two parts, the client and the server part. And the whole business logic here will be put in those two red boxes, which are like the room object of the client and the room process on the server side. And another thing which is worth noticing here is that we are having two communication channels. The first one put on top is the signaling channel. It's based on some TCP protocol, and it's meant to send some controlling messages. So for instance, once some client joins the server, server might want to broadcast such a controlling message to all other clients who are already in that room, but the new peer has connected. Another communication channel is the one visible on the bottom. So we have like some kind of UDP or generally datagram based communication there. And those two blue objects, which are like Membrane WebRTC and RTC engine, are communicating like without anything in between using that channel, and they are exchanging the media, so video and audio, like basically. And when it comes to the behavior of that system, we need to, Membrane WebRTC needs all to communicate with RTC engine also using that signaling channel. And we need to somehow pack these controlling messages or so-called media events, as we will refer to it later, and transmit them via that channel. So once there is such a media event, our room process, our room object here and the room process here will need to transport them via that channel. Okay, and now let's focus on this part on the server, which can be considered the heart of the server, which is the RTC engine. So let's get back here for a moment. So it's this part. What is the reason why do we have this part? Well, it's the the element which will be displaying that media among the browsers. So as you can see, each browser has a corresponding endpoint. And that endpoint is responsible for getting the media from the browser and sending media to the browser. And what is important, these endpoints are also talking with each other, as you can see. And they work in somehow, we can call it the subscribe, well, publish and subscribe mode. So once the endpoint is capable of sending some media, it publishes some media track. And other endpoints can simply subscribe to this track and start receiving data from the endpoint. But the question in the subtitle is what makes it so modular? Because in the membrane framework, referred to the architecture of the RTC engine as the modular RTC engine. Well, basically, it means that we can create our own modules, our own endpoints, as you can see in the picture on the scheme right now. So, for instance, we can create our custom endpoints, just like this HLS endpoint, which will subscribe to all tracks from other endpoints, perform some business logic, in that case, creating the HLS stream, which can be, for instance, stored on the disk later on. So this is the point where we can add our own custom business logic to that module. Okay, so right now we have discussed a little bit about the architecture, and let's go to the coding part. Since I still have an instance of the video room running, so I will kill it and try to check out to the branch on which we have prepared some kind of template. Okay, and since the whole video room application is generally a Phoenix application, so we'll simply run it just as a regular Phoenix application. And now, as I said before, we are on this template. So it means that most of this boilerplate code is covered and already implemented. However, the most crucial parts of the system are not implemented, and we will implement them in a moment. Let's see how the things look right now. So what happens in case we connect to the room right now with these most important parts missing. So the first one connected, we can see that we can see ourselves, but once the other peer tries to join, they cannot see each other. So that's not the point, and we have to somehow repair it, and we'll do in a moment. Okay. So as I said before, our application has basically two parts, and we'll start with the front end part. So we will implement the room class, which was shown on the scheme. There is a little bit of code already here. So generally we have some fields and partially implemented constructor. And for instance, what we already have here is that we are creating a socket, this one which was meant to allow us the signaling communication. So we are creating it, connecting it, as well as creating a WebRTC channel via which we will send the signaling messages. However, we also need to create this blue box, which was membrane WebRTC object. And the whole definition of this object we need to provide the behavior of that object. And it's done with the callbacks mechanism, which we pass in the constructor. So let's start with the first callback. Just for a moment, it's plenty of code, so I will copy paste it here. And what we have is the onSend media event. So this callback gets called once once this blue box, the membrane WebRTC object, wants to send some media event to the server side. So what we do here, we simply push it via the channel. So probably it's quite easy to understand what happens. The other callback, it's much longer. However, do not here because generally the behavior described here is also quite easy. So this is on join success callback. Once we get accepted by the server, because the server can accept us or reject us when we try to join it as a client, we have to perform actually a couple of steps. First, from all our local streams, which are like the audio stream and the video stream, we need to put them inside the WebRTC object, all of these tracks, so that the WebRTC object can deal with the tracks we've put there. And we also need to add the video element for each of the peers inside of the room. Of course, we're using some predefined methods here, but there's nothing special about them since it's only dealing with the UI so like this add video element. Okay, here we go with the other method, the other callback, which is called onTrackReady. So as you can see, we have put our tracks, for instance, inside the WebRTC object, and once they become ready, this callback gets invoked. And what we do is that we are attaching that stream to the browser element, which is capable of displaying that media, so like the video or audio from the stream. And we have two other callbacks we're gonna implement, like on peer joint. So probably you can guess when this callback gets called, because it gets called when a new peer joins the server, and we have to be informed about that so that we can add the video element for the newly connected peer. So this is like what happens once some peer joins the server, and of course the corresponding callback on peer left, which gets called when a peer left. There are a couple of other callbacks described in the documentation of the membrane WebRTC class. However, we do not need them in our case, so we won't implement them. Okay, so as you probably remember, we had this communication here. However, right now, what we do is that we are simply passing the media events from the membrane WebRTC where they are generated via our room to the channel. But we also need to do it in the opposite direction. So we need the events sent from the server to be passed to the membrane WebRTC object. So we need to somehow fit that object with media events. And that's why we also need to handle a situation which might happen on a WebRTC channel, which is the situation in which we would receive some media event on the channel. And what we do, we call a receive media event function on the WebRTC object so that this media event can be transported to the WebRTC. So the constructor is right now ready. But as you could see, once I was connecting to the room, we also need to join that room, yes, because we're like clicking the connect button. And this, once we click the connect button, this method gets called, so the join method. And a really important thing to do here is to make our membrane WebRTC object really join the room, so provide a communication with the server, and we do it with the join methods, and we can pass some custom options like our display name to the server. So probably right now we are done with the JS part, and we can go to the Elixir part, because as I said, this is the Phoenix application and our backend is of course in Elixir. So probably it will be more interesting according to the name of the meetup. So let's refer to our scheme, because right now we are somewhere here. So we have to provide this bidirectional communication between the channel and the room, so that we can push the events via the socket once we receive them from the room, as well as to send some events to the room when we receive them from the socket and from the client side. So of course, what we have here is a process which will deal with that stuff. And of course, we have some kind of initialization of this process. But the behavior, so the thing we need to define here is simply can be done with implementing two callbacks. So the first one here, this we are sending media event to the room process once we receive them from the socket. So we are handling that media event and sending it to the room where we have our custom business logic. And the other way around, we do it with responding to a message. So once we receive the media event message, we simply push it through the socket. So that's it when it comes to the peer channel. And now probably we will have to deal with the most complicated part of the system, which is the room process, which describes how the server generally works. And of course, we will need to define some callbacks since it's like behavior driven. So let's start. Let's do it. Our video room is a Gen server, and we need to provide the initialization of that Gen server. And now probably you can see a large amount of code, but do not fear it because it's almost only defining some options. And in really most cases, all you need to do is to simply copy them from the documentation. And of course, if you need to change them, you can do it and basing on that documentation. But like these three lists are simply options. What is important here is how we start the RTC engine, and we do it just over here. So we are starting and getting the process ID of the newly created RTC engine process, and we register ourselves, so our room process inside that RTC engine, so that the RTC engine will know to who to talk when he wants to send some media events to the client side, for instance. And of course, we are keeping that in our state all along with the peer channels map, because we have to have a way to where we have to know where to direct the messages from the room to a particular peer channel. Okay, so right now our initialization is done, and let's start implementing the callbacks. So maybe just for the beginning, let's handle the situation in which we are told to send a media event to the client side. So we are, this implementation here comes into parts, since we can receive such a request either to broadcast that message, so to send it to all peer channels which are currently held in our state, as we do here, or we can do it to a particular peer channel, so to a particular client. And we do it simply with plain like kernel send function. Once we are done with sending the media events, we can, okay, I haven't probably fulfilled the whole function, so give me a moment. Okay, right now we are ready. And now we're gonna handle some other messages which do not need to be transported to the server side. An example of such a message is the new peer message. So it's quite a big one, so I will try to describe it in details. But maybe it will be easier if I would refer to the scheme once again. So as I said before, the place where we hold the business logic is room process. And the idea is that once the client requests to join, the media event is sent from the membrane WebRTC, and of course it's transported via the socket to the server side. And we do not open that message anywhere here. We are simply feeding the RTC engine with that message. And RTC engine sends the room process a message, which is somehow the way to provide we can provide our custom logic in that way, because once we receive such a new peer message in the room, we can decide whether to accept or to reject the client who tries to connect. So we can, for example, create a room in which we would allow only 10 people in a particular room, and all other clients would be rejected. So let's go back to the code and see what I've pasted here. So as you can see by the logger message, we of course are accepting the peer. We do not reject. We are nice to the client who tries to connect, and we are creating the endpoint. So as you have seen on the scheme where I was describing the RTC engine, each browser has a corresponding WebRTC endpoint, and this is where we are creating the endpoint. So generally, we are passing a couple of options predefined in the initialization step, creating that endpoint, and then we make the engine accept the peer. As I said, we can also reject the peer in this place. And after that, we can add this endpoint to the engine, and starting from that point, our RTC engine would have one more WebRTC endpoint inside, which would start to receive the media from the browser, which would publish the tracks received from the browser, and some other endpoints could simply subscribe to that endpoint and start receiving the tracks and relaying them to other browsers. Okay, and following on the behavior implementation, we have another callback, which is our reaction once we receive the message that the peer has left. We are simply logging that fact. Of course, we could do some other stuff, but it's probably nothing more interesting to do here. And of course, even more important callback is the callback which defines our reaction once we receive the media event message. And what we do is we feed the RTC engine. So referring to the scheme, once we receive a media event message, we have to pass it to the RTC engine so that it can behave properly. Okay, so generally speaking, we have implemented a couple of callbacks, both on the client side and on the server side. And let's try to check whether it started working. So mix, and we are starting the server. Now the big moment has come. We will see what are results of our job here. Let me check. Okay, so let's try to connect. So the first peer connects, but it does not mean anything. Let's try to connect the other peer. And as you can see, we have the starting point result. So we can see each other. And just at the end, I'm not sure how much time left do I have. Do I have any time left?
Someone said 8 minutes. We can agree.
Okay, that's great, because I would like to show you what happened on the server side, because we have some logs, because we are using a logger, and we have tracked some information what happened within the server. So as you can see, once the first peer joined, it generally the server spawned the new room process, and this room process started a new RTC engine. So this happened once the first peer connected to the room. And of course, another peer has connected to the room, and the tracks started being relied, so between the endpoints inside the server. So you can see that we have here like a VP8 track, which stands for some video codec, and the Opus track, which stands for audio codec. And it started transporting between the endpoints. And once the other peer joined, of course, he also started sending his media to the server, and among the endpoints, this media also started being relied. So we can see this. And of course, we can, where is it? Oh, here we are. We can leave the channel, and probably we should be informed about it, or maybe we are not. Okay, but generally speaking, we are keeping track on what happens inside the server. And that's all I wanted to present today, but if there are any questions, so feel free to ask them. I did. Okay, so probably that's it. Thank you. Oh, okay, so we have a question.
Hello. First of all, thank you for the job you're doing. It looks amazing. My question is, as I understood, you develop both client and server-side library, correct?
You mean like the library?
Yeah, library.
Well, yes, there is like the support for the WebRTC for like dealing with media based on the WebRTC standard on the client side, and we have this RTC engine module, which is also a part of the membrane framework, and it deals with this stuff connected with this relying media between the endpoints.
Okay, so can I work on client with different streams like audio, video, or screen sharing?
Of course, yeah, that's possible. All you need to do is to add another endpoint, for instance, which would be capable of sending such and receiving such media and working with that media within the server.
Okay, and another question: can I create multiple rooms on the server?
Of course, yes.
And send, let's say, I can make some processing and then share this stream to another rooms.
No, the stream. Okay, so you mean like sharing the stream
inside of server processes? Let's say I have separated rooms, and maybe let's say I want, I don't know, add subtitles and show to the, I don't know, 10 special VIP users video with subtitles or translated with some delay, for example.
Okay, but we are talking about like the one room or
different rooms. So there is...
Yes, of course. I mean, this room is just like some kind of abstraction.
So server rooms, it's also like a client's.
I'm not sure whether, well, I wouldn't say that it's like a client. Could you maybe describe more precisely?
I think that because I am also involved in, maybe can I get it?
Maybe from Bartek.
Okay. So because I'm also involved in developing this library, so this is of course possible. Everything you need to do is to implement a new endpoint, and you will add an endpoint to our membrane RTC engine instance, and this endpoint will be responsible for processing your track. So you don't have to pass tracks between rooms, but instead you will create a new endpoint, add this endpoint to RTC engine instance, and this endpoint will subscribe for track, modify it, and will publish a new version of a track.
Okay, that's what I wanted to know. Thank you.
Okay, so thank you, Michał, because Michał was generally preparing the presentation along with me, and I'm like presenting, and Michał is much more experienced when it comes to the membrane. So thanks for answering. Okay, so are there any other questions? Okay, so I would like to thank you for listening or for watching.
Thanks a lot. Okay, so now it's time for our final presentation today, the last one before the pizza. Next, as I said, we're not only doing multimedia stuff within Elixir, we also have a bunch of backend teams using Phoenix. And next up is Piotr Szeremeta, who is probably one of the most experienced Elixir developer here. Yeah, the experience is euphemism for old. So he will be talking about Ecto and dealing with Postgres. Okay, we have the audio ready. Okay.
See my screen? One. No. Mm-hmm. Mm-hmm. Okay. Mm-hmm. Can you see anything? No. What happened? Yeah.
Yeah, great. So let's get started.
Okay. Welcome everybody. Thank you for your attention. And as Bartek said, I am very experienced, so you should have very high expectations of this presentation. Not really. We'll focus on mainly on my experience developing backend applications using Phoenix and mainly Ecto, and particularly using this Ecto framework to unleash PostgreSQL and its functions in all of its glory. Okay, so for a couple of years, I've been developing race applications, Django applications, and what I saw there were our RMs, which were using basically active record data mapping structures, which was fine in a lot of cases, making new records, creating tables, creating new records, updating them. Okay, it's all very easy. But once we go into hard stuff, it all becomes very difficult to actually provide business value to the customer. For example, we need to aggregate data across many tables, create models that are not particularly mapped to one table, and or find statistics on across many records. And they, of course, our standard ORMs are fine, but they also have many downsides. But Ecto is different. Funny thing, when I was trying to find what actually is Ecto, what does it provide, what it actually does, it isn't defined as some object relational mapper, resource mapper, but it's a toolkit for data mapping and language integrated query. What does it mean? It means that it is it provides us with tools to fetch data, to map it, to comp it into something that is actually usable without much without being too fussy about underlying data structure. But so I have too large heart.
Yeah, probably. Just give us a second. Should be better. 1 second. Yep.
Okay, anyway, so when developing these applications, Ecto proved to be very simple, as in I can take any single element in Ecto toolkit and use it without understanding the whole structure. I can use genset just to message the data into particular shape, or I can use just 3-point query to make simple SQL queries into database without using any other stuff. It also, what I also found, that it is very flexible in changing needs. As you can maybe those of you who have developed backend applications probably know this story. When your customer comes to your company and he wants something very simple, there is something that can be ultimately translated into block structure. There's users, they have some privileges, they can create posts, they can comment, and maybe even they can vote. And it is so easy that it doesn't need much attention. We can beat it with literally anything. But it becomes harder. Oh, low battery. It becomes more difficult with time. Customer wants to build a lot of new features that are not necessarily suitable for existing data model. And what we have are tables and columns and data structures that are not that do not conform to the new requirements. And with time, as we are trying to massage our classes, our records into new shapes, it becomes more difficult, more cumbersome to maintain. So Ecto can help us with that, just simply by simply by allowing us to focus not on our underlying data structure, such like tables and columns, but to define our own data structures and structures that use data that has been given. It instead of being driven by our schemas, we are using them for our purposes. Okay, so over developing these applications, we came up with a couple of general tips that help us work with Ecto. And these are the most general ones, which are keep schemas small and focused. What we have what does it mean? It means that instead of having large models with such like this, we have some standard user which defines all fields that are in the database, or the columns are there. We have access to every single data data from the row, and it always available accessible only through generally accessible methods, such as here all, which loads every single column from all the rows. And we are also and user becomes this Uber model that we use in every single context that may not necessarily be suitable. For example, well, let's see what we can do to make it a little bit better, a little bit more customizable. Okay, so instead of having one single file with user model, we have a couple of smaller modules which define user, which use user table, but they are all used in different contexts. So for creating accounts, we need just email and password in plain text, of course, and to start in database. There is no reason to bother it with some first name of other sensitive data, and accordingly, you can also use trend sets which affect only this particular model and are used in only this one context. So we don't use generalized trend set function to update any field, but only those that given user in given context can update or change. In this case, email and password. But in other contexts, let's say what we are seeing are posts of the user that he has created, and we want to just display a couple of information about him. So we don't need email, we don't need password. All we need is display name, avatar URL, and avatar URL, and fields which also can be which also lowers the amount of data that we need to fetch from the backend. So what is also important is that this context that I mentioned, which could be, for example, creating accounts, new sessions, creating new posts, or maybe just managing users, should be small and focused. And why? Well, because small amount of information better fits into our heads, and also because we can name them differently. We can create in our heads. We can create data models which better translate to business specification, to domain language. this is very common problem that we have user model which does basically everything, but user doesn't really makes sense in the context of let's say account management. It doesn't. It is something much smaller and much more focused. We are not necessarily interested in user, but we are interested in him as commenter, as blog poster, as manager, and this allows us also to use language that better translates into business domain. Okay, so things that we can use. Okay, so these were just general tips that I found useful during backend development, and these are some specific things that you can use in your projects. So not all fields that are defined in schemas has to translate directly into columns in the database. Some of them can also be marked as virtual, which means that they are skipped by Ecto whenever it loads data or preserves it into database. And this allows us to create structs which are better suited to particular needs. So, for example, let's say that we want to just retrieve users that created more than 5 comments, and we call them super commenters. And we can use standard methods provided by Ecto schema, which is like creating relations with comments has many relations, and we can check the status for every single user, fetch data, count comments, and so on. But it is not very nice. Doesn't look very well, and it also is prone to n+1 errors, which means that when we load many users, we'll issue this query many times over. How can we do it better? Using virtual fields. Instead of asking every time using some function about given commenter status, is he super or not, we can create virtual field that we populate when loading data. And because we are in this context of commenting and not, for example, administration or displaying posts, it makes more sense to have these fields as opposed to having it on this large user model. And we can populate this field instead of using for every user separately. We can do it at the moment of loading them from the database. And in this example, we can find all commenters which created more than 5 comments just using the database, and use it as a subquery in general query that returns users. And by using select merge, we can populate this virtual field with the data from a subquery which is not related to any particular column. This way, end user of our code, which can be developer, who can be you 1 year from now, or your colleagues, do not really care how this data is created, and it is whether this is stored in the underlying column, whether it is collected over multiple multiple tables, or maybe using generated columns functionality in Postgres. All your colleagues care about is that there is field on this struct which returns data, which makes it much easier to develop to use these structs in front-end context. Okay, so what is about unleashing Postgres? It means that extending Ecto query APIs is much easier than in other frameworks. For example, in Active Record in Django, when many times we have to use handwritten queries to get exactly what we need. And Ecto provides a couple of functions and operation which, but by default, that we can use from the get-go, but we can do more. We are not dependent on framework developers to keep up to date with database development. We don't need them to create new functions for every single version of the database. And we can do it very easily using macros. So in the recent version of Ecto, we finally got a JSON extract path, which enable us to work with JSON data, which enable us to fetch data from deeply nested JSON B fields and JSON 2. But it has some limitations. It doesn't allow us to. It doesn't use indexes that we may create on the JSON B fields, which is less than optimal. So why not create our own accessor which uses functions that can be optimized by Postgres, and we can use it. We can do it using macros. In this case, we create in key macro which translates into fetching operator that we can use in our queries. So at the bottom we can see that we can use in key just like it was sum of any other Ecto provided function, just as if it was Ecto query, part of Ecto query API. But we can do even better, because certain operators provided by Elixir can be overwritten, and we can use them not as functions, but as operators which have left and right side. So we can make this operation even nicer looking. And this symbol, which is till the end to modern science, can be translated into this nice looking API. And we have used it exactly in one of our projects when content had to be translated in multiple languages, and we decided to store this and store it on the backend using JSON B column, and keys would be languages and values translations. And it was a great idea until customer decided to implement to use some decided that users need searching functionality across all those languages. And how how could we do it in optimal way using indexes? And considering that these texts that in columns could be very big. So we developed this created this little macro which uses built-in into Postgres functionalities which which are optimized for searching in large text, and they are even optimized for specific languages. So whether it was English, French, German, and so on, we would have queries that are optimized for any kind of any kind of text. And so we could use it like this without in optimized way without having to worry about underlying implementation. Okay, so another fun functionality that we have discovered that worked really well for our applications was aggregating data in preloads. So those of you who have used Ecto know very well that we can define has-many association on schemas, and we can preload them, which means that instead of issuing in this case for every comment issuing querying the database for every commenter, we can just issue two queries to fetch commenters and comments, and underlying data structures are loaded and in optimized manner. Okay, this is pretty standard stuff. But what we also can do is to use preloads to load formatted data. So instead of passing just a keyword to preload we can provide a function which will issue query to the database. So what Ecto will do, it will load the parent data, fetch foreign keys, fetch primary keys for this query, and pass them to this function. And what we should do is to use those primary keys to find data to return data that we need. So in this case, in case comments are very long and we don't need the whole content, we just need the preview. We can instead of loading them all, we can use something else, which is preloading with function. In this case, short comment preload. This will fetch and this query will fetch all the comments along with user ID in this, and shorten their description using Postgres internal functions. This way we don't have to transfer over the network the whole content of it, but only this particular fragment that interests us. Okay, so this was a very short presentation because it is just a taste of what Ecto can do when we think outside the box, outside our the mines that were formed by using active records. Instead of defining all those models, all those classes that fetch every possible data from the backend, which are dependent on those schemas, and make it very rigid. It forces us to always keep in mind what is underneath it, what is in database, what is in tables. We can think outside the box. We can think, okay, there is this data, and there's this data. We can use it, but the business domain that we have may not necessarily translate one-to-one, and it will be easier for us to name it, give it other name, fetch just a subset of this data, or fetch aggregated data. And this allows us to create applications which are much easier to develop, much easier to manage, and to think about, and of course create them faster and making fewer mistakes. Okay, thanks a lot. Thanks for your time. Any questions? Okay, thanks then.
Thank you very much. And okay, I guess that's it for the presentations, and we can say goodbye to the viewers online. I can mention that we are planning to organize this event like somewhere around in 3 months, probably, but it still may change. And for those of you who are at the office, a few of the technicalities. The beer is in the refrigerator in the kitchen behind my back. If you would like to go to the bathroom, it's near the elevators outside of the office doors. And the pizza should arrive in at most 20 minutes or